Sweet. Okay. Kind of like the sine rule for angles, there are two cases. So you're just going to think about when you're looking for an angle, whether or not your angle is obtuse or if it's acute. Now with sine, so I just want to, I guess, give you a quick, let's do a little bit of an aside here. With sine, let me draw my now sine is positive and also positive there. So when you get your solution, you've kind of got to decide whether it's, or the question has to tell you whether you're looking for an obtuse or an acute angle, because you don't actually know, because these are going to be positive in both cases. So what I mean by that is when your last line of working out is theta equals sine minus 1 something, then it's going to be positive no matter what. But in the case of cosine, so cos, if I drew the same thing, that's not even a circle, it's kind of impossible for this to happen because cos is positive there, because it's the x coordinate, this one's the y coordinate, but it's negative here. So in order for you to even be considering an obtuse triangle, then you're going to have a negative somewhere in your calculation, which is why in theory the cosine rule is a little bit easier than the sine rule. Even though it's a little bit longer, it's easier to determine whether you're looking at an obtuse or an acute angle. So the question doesn't actually need to tell you, because it should be pretty obvious, and I'll show you what that kind of looks like. Now, hi Georgia. Let's just recap. So c squared equals a squared plus b squared minus 2ab cos c. That was the cosine rule. Now, I want to find an angle, which means I kind of want this to be by itself. So what I'm going to do is I'm going to rearrange. I'm going to move those two over there. So I've got c squared minus a squared minus b squared equals minus 2ab cos c. Okay, now I'm going to divide by minus 2ab. So c squared minus a squared minus b squared on 2ab equals cos c. Okay, I don't want to have to remember an equation that has minuses in it, so what I'm going to do is go cos c equals, I'm going to pull this minus here out to the front here, and then I'm going to put it up here. So it's kind of a weird step, but basically 2ab is going to be positive. So think about it like this: if I have minus a half, that's the same as 1/2 with a minus out here, and also the same as 1 over minus 2. So I'm just going to get this minus and put it up here, which is going to change all these signs. So I'm going to have instead, that's going to be positive, that's going to be positive, that's going to be negative. So positive, positive, negative. And that's the cosine rule for angles. So it's essentially, you don't only have to remember one of them, you just need to remember how to rearrange it if you wanted to use it to find an angle. Okay, now I've run out of room for this. Got my first triangle. Let's move him down too. Now I think it's quite obvious that this thing's acute, but let's suppose it didn't tell you that. If you're going to use the cosine rule, you require, just have a look at my equation. So maybe I'll draw a box around it. Oh, that's triggering. That's also triggering. One more. There we go. Maybe I'll leave it highlighted. Have a think about this. I'm looking for an angle, but in order to use my equation, I need A, B, and C. So I need all of my sides. Now, because I'm looking for C, I have to label C as obviously the thing I'm trying to find, which means little c, which is the one that has the minus on it, needs to be the opposite. So when I go to do this question, I'm going to need that to be little c, capital C, and then A and B can be whatever they like. Now, what I meant in terms of this, you require all sides of the triangle in order to use the cosine rule. Okay, so let's suppose I've just got this. I'm trying to find what question mark is. So just using cos question mark equals a squared plus a is 7. 7 squared plus 8 squared minus 2, 7, 8. No, what am I doing? Minus c squared. Maybe I need this. So a, b, 7, 8, c, 9. Okay, good. 2bc is over here. 2ab, 2, 7, 8. Okay. So all I've done is substitute all my information into this. Now what am I doing? This is equal to, just off the top of my head, of course, because I can do all this in my head, 32 over 1. Okay. Now, just have a quick think about this. So forget all that exists. I've just got cos question mark equals this. Now, I've got a positive value for cosine here. This is basically saying my x value is this. So my x value somewhere along this part is 32 over 111. So in other words, I have to be looking for an acute angle. Now when I go question mark equals inverse 32 on 12, then this is equal to 73 degrees. Okay, so that's pretty straightforward. Like I don't want to confuse you too much. It's just basically substitute into a formula and then do inverse cos, and then you end up with 73. That's fine. Now, when you end up with something like this, where it's quite obviously obtuse, maybe you don't know that. Maybe it doesn't really. That almost looks 90. I don't know. So maybe it's ambiguous. Let's just do exactly the same thing as before. I'm trying to find that, which means that's got to be little c. A and b can be whatever. Cosine rule is cos c equals a squared plus b squared minus c squared, all on 2 times a times b. Okay, so when I type that into the calculator, here's where it gets a little bit strange. So I get negative 60 on 336. So what that's basically saying is this is an x value, it's in the negatives. So if I have an x value, here's x, which is in the negatives, that means I'm looking for a value that's here. And so that means I'm looking at an obtuse kind of triangle. So this tells me that it's obtuse. Okay, but this is where you got to be a little bit careful. So when I evaluate this, so when I chuck this into the calculator, what I get is maybe I'm okay. 2, 9. Okay, I'll just check that. How many radians? Yeah, okay, I get 100. I thought I might have gotten the acute version, but that's fine. Okay, so really there's nothing to think about. When you get to here, just realize that your answer is probably going to be between 90 and 180, just simply because that's negative. But that's, again, it. So there's not really that much to it, just recognizing that cosine rule and the sine rule can both be applied to triangles that are just acute, but are also obtuse. So the cosine rule is probably arguably easier than the sine rule, except for the fact that it's a little bit more complicated to look at, but it's a bit easier to deal with.